Notes 9.4, angles created when lines intersect. Remember to write your name and remember to label it OMA number 43. Okay? Remember that I won't accept it unless your name is written on it, so it's really important that your name is written on the actual piece of paper that you take a picture of. Okay, so we're going to make sure we write the title, and everything that you see here, you can write it on 1 page or 2 pages. It's up to you. Okay, here we go. So, the first thing is we want to make sure that we imagine our paper kind of drawn in 2 columns. So this diagram of 2 lines intersecting can go on the left side, and the writing over here can go on the right side. So just imagine it kind of split in 2 parts. This is really the top half of the paper. So the first thing I want to ask is, can you easily spot the obtuse, which I'm going to write in green, and the acute angles? Can you easily spot them? Go ahead and pause the video and see if you can label those. I would do it in pencil, but label those lightly. See if you're right, okay? All right, let's see if you got it right. So, obtuse, we have in green, that would be this angle is obtuse. And this angle is obtuse. And then I'm going to switch to blue. So this angle here is acute. And this angle here is acute. So what do you notice about these? Well, the first thing hopefully you're noticing is that vertical angles, that's one of our vocab words, vertical angles equal each other. So what are vertical angles? Well, there's 2 sets of vertical angles. The acute angles, each pair of acute angles in this diagram, they're vertical. They're pointing to each other. See how their angles are pointing to each other? Okay? And I'm going to use gold for the next word. So adjacent angles, they add up to 180 degrees. Okay? So any pair of acute plus obtuse angle in this diagram equals 180 degrees. All right, let's back up a minute. So let's go back to vertical angles. So both acute pairs equal each other. What do you think's true about the obtuse pairs? They equal each other also. So their angles point to each other as well. Okay? All right, let's jump down to the bottom diagram. So could you find the 3 missing angles if I gave you one of them? So let's say I gave you an obtuse angle. Okay, so that would mean that I gave you degrees that was just more than 90 degrees. Okay, so here's one of the obtuse angles labeled with 121 degrees. All right, so pause the video, see if you can figure out what the other 3 angles equal. Okay, all right, so what would it mean if this angle was 121 degrees? Well, since this angle is pointing to this angle here, okay, that means that this angle is 121 degrees as well. The reason for that is because they're vertical. So anytime 2 lines intersect, and you don't have to draw this, but anytime 2 lines intersect, this angle here equals this angle here, okay? And the same thing is true for this angle here is equal to this angle here, okay? So angles that point to each other are vertical, all right? All right. Now, we found both of the obtuse angles, but there's more angles to be labeled. So what do we do to find this angle here? Well, we think about last week's lesson where if we had two angles that were side by side, so here's part of this half circle here is 121 degrees. How do I find this one? Well, that's easy. I just take what I know about a half circle or a straight line. I know that it equals 180 degrees. I subtract the obtuse angle, which is 121, and I get my acute angle. So 10 minus 1 is 9. 7 minus 2 is 5. Oops. Okay. And I end up with my degrees, my acute number of degrees for this angle. Now, if this angle is 59 degrees, then the angle it's pointing to, which is over here, is also 59 degrees. Okay? All right. So, again, you don't have to have this green intersection, but yes, write down, oops, that was weird. Write down all of this work, all of the writing, okay? Make sure you have the little questions that I've written, all right? We're going to move on to the next page. Okay. So this is really the bottom of your paper, or maybe it's this next page of your paper. Doesn't matter to me. You've got plenty of pages left in your notebook, hopefully. All right. So the diagram below is a set of parallel lines. Okay. So who are the parallel lines? Well, this line and this line, they're parallel with each other. They're often shown as parallel lines because they'll have these little symbols on them. Okay? Sometimes they're like that. Sometimes they're just identified as parallel. Sometimes they have letters like M and N, and they might say up in the problem, M and N are parallel lines, and they're cut by transversal line T. So a lot of times they're labeled. For this activity, for this exercise, I'm just going to leave that out. We're just going to talk about the angles, okay? All right. So, not all parallel lines cut by transversal will always be laid out in this way. They might be standing up with a transversal going through them like this. They could be laying to the left with a transversal going through them like this. There's lots of ways that we could see this diagram. I've even seen many parallel lines. Oh, those aren't parallel. Those are ugly. All right, let's try again. I've seen many parallel lines cut by one transversal. And the truth is that the same outcome occurs. But we start out with a very basic model, which is just two parallel lines cut by one transversal. Okay? All right. So, I'm going to read it one more time. The diagram below is a set of parallel lines. It's cut by a transversal. There are only two different measurements. I'm going to underline that. That's really important. There's only two different measurements in the entire diagram. Okay? So first, label the obtuse and acute angles. Go ahead and pause the video. Think about what we did back here. I was using green for obtuse and blue for acute. I'm going to stick with that. Okay? You don't have to, but I'm going to stick with that. Pause the video. See if you can figure out who the obtuse angles are and who the acute angles are. Okay. Hopefully you notice that this angle is obtuse. Okay. And then hopefully this was clear that this angle was acute. Now, as I start to fill them in, there are 6 more angles in this diagram, okay? There's an acute angle here. Notice its relationship with the other acute angle, kind of diagonal, okay? There's an obtuse angle over here. There's another obtuse angle over here, again, diagonal. See the diagonal relationship? There's an acute angle over here. Oops. There's two more. There's one more acute angle here. And the last obtuse angle is over here. Now just a review, obtuse is greater than 90 degrees and acute is less than 90 degrees. Okay, let's jump over to the second part. The second part says, could you find the 7 missing angles if I gave you one of them? All right, well, let's see. If I gave you the acute angle, let's say, if I gave you 67 degrees right here, well, what would you know about all the other 7 angles? Well, hopefully you're catching on that the acute angles have a relationship, and some kids in the past have called it like a lightning bolt effect. Okay? They travel through the intersection of each, across the transversal, okay? So that would mean that this angle is acute, this angle is acute, and this angle is acute. And what do we know about all 4 of these angles? They're all the same. In this diagram, all 4 acute angles are equal. Okay, all right, so let's fill those in. Here's one, 67. Here's the other, 67. And here's the last, 67. Okay, I'm going to switch to green. Now, if I want to find what the other 4 angles are in a diagram like this, all I need to do is subtract from 180 degrees to find the other measurement. Whether it be obtuse or acute, whatever one you have, all you need to do is think about, okay, well, these make up a half circle. If I know that this angle is 67 degrees, how do I find the other angle? Thinking back to last week, okay? So, we need to do 180 degrees minus 67.
Alexa, stop.
So we get, sorry about that. Let's see. 180 degrees minus 67 is a 3 and a 1 and a 1. So let me just show that real quick. We get, this is, I'm going to write this off to the side. This is a 10 because we borrowed from the 8 to make it a 7. Okay? So here's our obtuse angle, 113 degrees. Now, if that angle is 113 degrees, that means the diagonal angle here, the vertical angle, is 113 degrees. So we can label that one.
Jake, did I miss it, or?
That means this angle is 113 degrees. And that means this angle is 113 degrees. Hopefully you're noticing a pattern in the way the angles are laid out. Okay? So that's it. Take your time. Write everything down. Talk to you soon.